Let me also place you guys on mute for time being. Okay, so what's the topic for the day? Okay, so as we all know, we are done with lot of topics and we are left out with few topics. So what are those topics that I would be covering today? Okay, so I'll start with the wireless topic, which will deal with topic number 3.3 series, and there are one more topic for wireless, which is 1.2 series. Okay, so two topics, one is 1.2 series and the other one is 3.3 series. You don't have any wireless topic or practical in case of your NRC top in the case of NRC module. Okay, NRC module is free from the wireless technology. There is no concept because it's a advanced routing switching topic. If in case you are more focused toward wireless, then there is a dedicated concentration paper in CCNP which is completely for wireless. Okay, but since we are into routing switching, the NRC module don't cover any wireless topic. Okay, so it's just NCore which has two two series of topic number. One is 1.2 series and 3.3 series, which is uh, covering few basic wireless topic. Okay, there is no practical, it's just the discussion on the wireless technology. Okay, fine. And we have also done a class on Thursday, which was, okay, I think I have marked it already, GRE and IPsec. Okay, so we are doing great. Okay, so we have just few more topics left from both the side. All right, so let me save this. Okay, so let me just write the topics that I'm going to discuss today. So this is your day one. So we will have total of 2 days to cover wireless. Okay, so this is your day one for your wireless, and today I am going to discuss about wired and wireless technology. Okay, a quick similarity, differences, the benefits of wireless. Okay, we are going to discuss about BSS, which is nothing but base service set. We are going to discuss about RF. RF is nothing but a radio frequency. We are also going to discuss about channels. Why do we use channel in the case of wireless technology? We are going to discuss about encryption, right? Because when the packets are moving in air, anyone can hack those packet or decode the packet and read the content. So we have to make sure the packet which are in the air has to be properly encrypted, so that only a rightful person can view that packet. Okay, and at the last topic here would be the mode of deployment. Okay, pretty much lot of topic for the day number one, and day number two would be the rest of the topics. Okay, so I'll try to keep one practical. So to have a practical for wireless, we cannot do it on GNS. Okay, so the best would be making use of packet tracer, because packet tracer has a WLC controller and a lightweight access point, which is required in order to see if the configuration is right, or to see the SSID and all other things. Okay, We will see. We will try to make a lab on packet tracer. I'm not sure because it's the first time I'm trying packet tracer. So we will give a try. Okay, we will give a try where I can deploy a WLC. We will keep a switch and we will keep two access point, light access point. Okay, and we will try to see what is a GUI, graphical interface of WLC, wireless LAN controller, looks like. So there will be plenty of options like SSID that you can configure. You can configure the encryptions, you can configure the MAC address, and a lot of other things. Okay, so it will be not very full-fledged kind of production kind of deployment, but we can try or we can see how this wireless looks like. Okay, fine. So we are good to start with the first topic, that is wired versus wireless. Okay, so if you all remember, this whole CCNP was like 90%, whatever we discussed was over on wired connection. Now let's say 5 to 10% is something which we are talking about wireless in this syllabus, right? So what do you understand by wired connection? So the moment I say wired, so you should strike with this word, Ethernet. So we have discussed about the history of Ethernet, how the Ethernet was evolved, how the advancement was happening in the Ethernet, right? So it was like in 1980s onward till 2020, there had been a lot of improvement done in the Ethernet technology. Okay, so the Ethernet technology or the cables that we had long way back were like Cat 2, okay, Cat 3, which used to be only supporting like 2 to 10 mbps of speed, and later on those cables were improvised. It went to 4, 5, 6, 8, we have 10, right? And we know the speed of each one of them. Also, if you talk from the technology point of view, Ethernet is one such technology which was initially called as Ethernet, okay, which used to support like 2 MB per second. Then we have something called as Ethernet, which was supporting 10 Mbps. Okay, yeah, 10 Mbps or 100 Mbps, sorry. And then we had Giga Ethernet, which is 1 Gbps, and so on, right? So a lot of things in the case of wired technology. Now, when we talk about wireless, we have to remember the IEEE standard of wireless. Okay, that is 802.11. It's a open technology. Okay, there is no uh, there's nothing called as what do you say, a paid version or something. Wireless is free or open to everyone. You can also work on that particular technology and you can just contribute to the community. If you have a handheld device which is capable of this particular standard, that means you can make use of wireless, right? So there is nothing that you have to pay for wireless technology and use it. Yes, the services, the packages is a different concept. So if I want to make use of a broadband over wireless, then I have to pay the broadband company. If I have a SIM in my card, I have to pay them and take the data services, right? That's a different thing. That's a package. But I don't have to pay anything for the wireless thing. Like in case of wired connection, I have to pay for the cables and I have to plug it, and then only I can make use of it. And on the other side, I have to also bear the cost of ISP, the service provider, right? So there are a lot of costs involved here. Whereas here, I just pay for the package. If my handheld is running on this particular standard, I'm good. I can connect to any ISP and I just have to pay and make use of it. Okay, so that's a brief about wireless versus wired connection. If you talk from advantage and disadvantage point of view, Okay, so let me say wired over here and wireless here. So you all know that wired is something which is physical in nature, right? So the moment I say physical, so that means a user has to be on a fixed location, right? So if his computer is been hard coded or hard binded with this cable, which leads to the switches, so basically he cannot move around. He has to be in front of that computer, right? So I can say that it's a fixed devices. Fine. What about the cable when we just lay around the corners of the wall? There is a chances cable will get uh, the cables might get cut in between, right? And if there is a cut, there is a chances that the packet are lost, or might be there is a slowness occurring because of all these issues. So I can say that uh, there are a lot of uh, issues when we talk from the wired point of view. Okay, cut, packet loss, and all other things. When it comes to security, what do you think? Whether wired is good or wireless? So basically, when we talk from wired point of view, the security is very high, right? We can have security at access layer switches. We can have security at distribution layer devices. We can also have security at core layer, right? We can have lot of security applied at every step. We can have private ACLs, access list, MAC binding, port security from layer 2 point of view. When you go to layer 3, you can have your AAA, you can have your dot 1x, right? There's so much the wired packets are being secured, right? Now let's talk from wireless point of view. So when we have wireless, it's all like free to roam. I can say that free to roam. You can carry your handheld device and just can roam around, and you don't have to be like seated in one particular point, right? Because it's after all the wireless signal which should be available on your device, and you're good with that. um, what about the packet drops and all those things? So packet drops are there in case of wireless, that happens due to interference. Okay, so let's say if this is one signal of my wireless, okay, at the same time if I have another access point, so let me tell this is a access point 1, I have another access point which is also sending its signal in this way. Now the portion over here will be interfering between two signals. So when this signal interfere, there is a packet drop. Okay, there is a packet drop. What about security point of view? So when this particular thing, the wireless technology, which was like in 1997, when it was launched for the first time, they were launched with open authentication method, and open authentication method is one such method which doesn't need any authentication. If your handheld device is capable on running this standard, and if your access point which is already broadcasting the signals on 802.11, they can form the connection and they can use the AP signals. Okay, so that used to be the first encryption method, the basis on just the signal. Okay, 802.11 handled devices were capable of getting connected with any access point. Now as the users increased, there was a they started a lot of issues, because anyone could connect to this boxes, anyone could use the bandwidth, right? And then we started up with some encryption called as WEP. We have 802.1x. So from security point of view, we have to secure our access point signals. Whatever wireless signals that the access point is emitting, we have to secure them, because it's not just about bandwidth utilization. There can be hackers and who are trying to steal your data, right? So we have to secure the packet. What about from cost point of view? So if you see from cost point of view, over here you need cables. Okay, cables need maintenance, right? What about in the case of wireless? We don't need cables, we don't need maintenance on the cable, we just need access point. And if you deploy access point, you configure one time, they can run for a couple of years without any major upgradation. But nowadays, you know that every brand are releasing their software every 2-3 months, right? So if you are looking for upgradation every 3 months, then you can take it forward. Otherwise, this is just a optional. Okay, software upgrade is optional. So if you just uh, deploy access point, it will run for like a couple of years without any ingenious interventions. Okay, so a basic difference between the two, wired connections and wireless connections. Okay, so what else? So I will show you one chart for wireless development. So this is your first release in 1997. So basically, there are two frequencies which will come to that. Okay, radio frequencies, which the wireless is supporting. We are talking about the network wireless. There are a lot of wireless frequencies. Okay, there are your microwave frequencies. There are the AMs, FMs. Okay, so there are a lot of frequencies, but we are talking from the network frequencies. Okay, the network frequencies, or the frequency from which we can connect our mobile or laptop. Okay, that frequency is something which we are discussing. So the two widely used such frequencies are 2.4 and 5. 2.4, if you see here, they were already supporting from the first release. Okay, so 5 gigahertz were launched like after 1999. Okay, so I can say that this is a latest technology, whereas this is one of the oldest technology. We will discuss which is better, uh, why do we have this 2.4 versus 5, what is the significance of the two ranges. Okay, so we will come to that. But from the evolution point of view, the first release was in 1994. It was just 2.4 which was released, and the maximum data transmission was only up to 2 Mbps. Okay, later on, like after 2 years, they came up with a new standard. There was once again only 2.4 which was supported, no 5 gigahertz, and the maximum data transmission was now being increased to 11 Mbps. Okay, because the users were increasing and there was requirement for a faster technology. Later on in 2003, that's like 4 years, the speed was still being improvised. So you can see that 54 Mbps now. Once again, only 2.4 which was supported, no 5 gigahertz, and the standard was labeled with G. Okay. Now what happened was, after this particular here, there was more number of users and there were more number of devices that were kept. Okay, so I can say that the access point were deployed next to next. So I have a access point 2, 1, 3. Now what happens is, this 2.4 frequency access point, they have a major drawback. Okay, the drawback is the working of 2.4 access point. They work in such a way that they cause lot of interference. Okay, so when there is lot of interference, the signal will drop. So what happened was, there was a requirement to release a better solution for that, and there was then the 5 gigahertz was launched. Okay, so it's also called as micro oven of frequency. So this was being launched 5 gigahertz. The speed was kept as similar to the previous version. Okay, what else was the requirement then? Then what happened was there were some devices which were 2.4, then they started with 5 gigahertz devices, right? Now what happened was they wanted a device which was capable of handling both 2.4 as well as 5. That's why you see the access point with two antennas, right? So one antenna emitting 2.4, the second antenna emitting 5 gigahertz. So you see here, it was this standard where the support for both was started. Okay, and what was the maximum data transmission? Up to 600 mbps. It was introduced in 2009, very high throughput. Okay, and then there were a lot of models. So you have this model which supports once again 5 gigahertz. The speed you can see, it's very high throughput. Okay, it was in 2013. We have also another model which is called as AX, which will support both of them. Okay, so 4 into AC. So basically you can expect the transmission is very high. Okay, and the Wi-Fi 6, it's capable of running Wi-Fi 6, which has already been launched. Okay, Wi-Fi 6. So this is a short brief on how this was being evolved, or what was the need for this. Okay, so those who doesn't know how this access points looks like, so let me just show you. There are n number of access point. If you think from the home user, okay, the home users access point, so you will hear the name, hear the company name like T-Link, D-Link, Netlink, right? Netgates. Okay, see this kind of access point, Netgate. So basically these are home users. They come with two antennas nowadays. Nowadays we don't go with one antenna because we all are aware of the concept of 2.4 and 5, right? So we prefer buying some access point which can have both the antennas. But since we are talking from enterprise point of view, these access point are something which we are not interested. Okay, we are interested on very high end access point, like something like this. Okay, these are called as Aeronet. These are access point which are placed in your offices. If you ever get the chance, you explore your floor, you will see the access point from Cisco would have been deployed, and this kind of access point would have been deployed. So what is a major difference between this kind of access point versus your home access point? Because both are emitting the same frequency. Even this is emitting the same frequency, whereas the home users are also emitting, right? One such difference which I can tell you now is, so when you talk from home user point of view and when you talk from enterprise point of view, these access point have various features which home user doesn't have. Something like RFID. RFID is a concept which you might have seen in a 5-star hotels or some VIP kind of uh, monuments, or somewhere where you expect a lot of VIPs visiting, right? Or some politician visiting those kind of areas. So what usually they do is they have some entrance kind of thing, right? So this kind of access point with RFID will be deployed over here. So let's say if a VIP is walking in, he's just entering. So basically the gate will open up, the receptionist will have all the details about this person, whoever is walking, whatever his ID is or whatever. He don't have to carry anything, just one RFID card is enough. So at the moment he just approach near to this access point will send the data to the backend switches. The backend switches will be configured with the security. Once again, this is all the network administrator does. Okay. And they have a separate terminal which takes towards the security check or whoever is handling that premises. Okay. So these are some high end technology or high end features that this kind of devices can support, which the home users cannot. So basically home users are very simple access point. We just have a play and plug kind of use, right? So we just order it from Amazon. Examples like Netgear, TP-Link. There are a lot of things. Okay, I'm just giving 2 3 examples. You have D-Link. So these kind of access point just cost you like might be uh, something like starting from $10 to $100. Very small range or pricing range of devices which are play and plug. You connect the ISP cable on one side. Okay, you have your antennas, and they are probably, you don't need to configure anything. They are ready to work. Okay. But yes, if you want to take the GUI interface of this access point, you want to change some password, you want to set some SSID, right? You're all good with that. If you see my access SSID name, I have not changed it yet. Whatever they gave me, I'm just using it. So that's why I say it's a play and plug. I didn't configure any VLAN for this. I didn't configure or was not bothered changing the password. So I just have the default password which they gave me, and I'm just using it. Okay. So that's from home point of view. But when you talk from enterprise point of view, these access point will be configured with lot of SSID. Now don't be confused with what is SSID. SSID is nothing but these name. So this is my first SSID. Okay. This is my second SSID. So I can say that one access point to get, so let's say this is one access point which will have such multiple SSID. So I can say this is for guest user, this is for the security team. Okay, I'm talking about enterprise now. I have one more SSID which is for marketing team. What is the backend happening here? So for guest SSID, this is for VLAN 11, which is connecting finally to your switch. Okay, whereas the security team of your company, which is having the SSID security, which is on a backend running on VLAN 12. Similar way, you have a marketing SSID. Let's say it's running on VLAN 13. So this is not just play and plug. In the back end, you're doing a lot of configuration as well. You're setting up dedicated VLAN which will take care of this SSID. These SSIDs will be broadcasted. Okay. So basically the wireless is considered to have a range of 10 meters. So in and around 10 meters, the signals are very good, but some access point have very good ranges. Now when you talk from enterprise point of view, they come with lot of uh, packages. Okay, you will get a starting model which will support 10 meters, but you will also get some model with higher price rate which will support like 65 meters as well, right? So the more you are ready to invest, the features will also get improvised. So when we talk about SSID, they just emit, and whoever is the rightful user, he will input the username and password, and he get towards, or he get connected to that particular network. Okay, so I can say SSID is acting as a network now. Okay, so in a short form, whoever is using the wireless, he may not be from network team, right? So to make it simple, we just give a SSID so that they can recognize. We can set it as guest, but guest in the backend is connected to a VLAN 11, which we know, we as a network engineer. Okay, fine. So what about access point? So if you just check the features of this, so there are a lot of things which this kind of model can support. So you can see what are the ranges that it can support. These are the encryption methods. Okay, you can also have your AAA radius server. Explore or Cisco services. Okay, compare models. So you can see here the different things. Networking. You can see they are talking from the data transfer rate, the protocol that's it's supporting, the management protocol, it's supporting SNMP as well. You can see the frequency band that they support. So basically you have to see all those things and then you will make a decision which kind of access point is really that you're looking forward. Antennas. Okay, so this supports 4 antenna. This support 2 antennas. So let's see how much does a simple enterprise access point would cost us. Not sure if it's a problem with Amazon or my internet. Okay, looks like problem with Amazon website itself, because other things are loading fine. Okay, so if you get time, just see the pricing for the access point, the Cisco AeroNet. They usually cost like from 500 ranges to like 3000 or might be 5000 USD. Okay, so they are an enterprise level access point. Okay, so let's talk from the packet flow for a wireless technology. How does packet communicate? Okay, so let's say if this is a user and this is AP, right? So let's say this would be the signal. Okay, let's say this is just unidirectional signal. Now problem with this unique unidirectional signals are that you will transmit the first signal and then the AP will transmit. So basically this is a drawback, the drawback of such kind of communication. Okay, so basically in the case of wireless we make use of bidirectional flow. That is, if this is a user and this is your access point, they can communicate on both end at a time. Okay, something like this. So this kind of flow is called as bidirectional, two-way communication. So you know that wireless communication is happening on a free space. Okay, they are not binded via cables. They are happening on free space over radio frequency. This is being called as radio frequency. The signals are referred to as radio frequency, in short form RF. Okay. Okay, so let's say this is a access point. Okay, I told you it's not a unidirectional traffic. So if you keep your access point, don't think that the access point is just going to emit radio frequency on this direction, so the users are have to be placed here. That's not the way. Access point will emit it on all the direction, 360-degree. Okay, they will emit the packet or emit the range in all 360-degree. So they form a kind of circle. So if I say this is access point, so I can say that access point range will be somewhere within this circle. Okay, so any user whoever is within this radius, so let's say the radius of 10 meters, they are all eligible to use this access point. Okay, so they can form a bidirectional communication between this, something like this. Okay, now in terms of wireless technology, the entire circle with along with access point and users, we call it as BSS. BSS is nothing but basic service set. Okay, and AP, the access point, is referred as heart of BSS because we keep access point at the center, right? So I can say heart of BSS. So the entire collection with the help of with including access point and users, we call it as BSS. Access point act as heart of BSS. There is something called as SSID, and there is also something called as BSSID. Okay, now what do you understand by these two things? So let's say the access point, whichever is emitting those radio frequency, they will have the MAC address binding, right? So basically this access point will have some MAC address in hexadecimal format. So let's say something in this format. So BSSID is nothing but it's the association of MAC address, okay, of access point. And what is SSID? SSID is that human readable string which user will use to connect. Okay, so in my case, I will not be able to see BSSID. This is from technical point of view. This is nothing but my BSSID will be nothing but the MAC address binding of my device or my access point. Okay, so let's say if I had another access point kept over here. Okay, and if I had a SSID which is emitted by this access point, so I would have told that there is a BSSID for this particular zone. SSID is just a human readable string which is for understanding purpose. So these are few terms we use here which is called as BSS, BSSID, SSID. SSID stands for service set identifier. Service set identifier. Okay, which is a text of your logical name. So this is just an overview of how access point is kept, the users, the SSID, the BSSID, and BSS. Okay, BSS is the complete collection. BSS ID is your AP with the MAC address association, because you can have multiple access point in this. So how do you say that that particular SSID was binded with that AP? This SSID is being binded with this. So you need some identification, right? We call it as uh, BSSID, BSSID ID. Okay, and SSID is just human readable. So basically, if you're over here, you might receive the same SSID from all the three. Might be you have a SSID called as security from here. You also have the SSID called as security from here, and you have SSID as security from here. So which one do you think you will connect? You will connect to that particular SSID which is very nearest to you. And how do you decide? So if you ever see, you will see something called as those lines of signals, right? So the green it is, or the maximum line that it shows, that means you're good, you are very near to that, and you will connect to that. If the SSID is showing just one signal or two signal, that means you are very far to from that particular access point, and they make doesn't make any sense connecting that. So you will connect to that SSID which is having the best or the highest signal. Okay, so this is overview from the terminologies, the wireless terminologies. Now let's talk from radio frequency point of view. RF, I told you what is RF. So if I say this is access point, so what is access point emitting? They are emitting the radio frequency, and that's how the users who have the handheld on 802.11, they're capable of understanding those frequencies. Okay, how do you think this packet will move in and out? So in case of Ethernet, or in the case of the wired technology, if I have a switch and I have a computer user, so the data is being transmitted over cables, right? The data are transmitted over cable. In the case of radio frequency, there is no such medium to send the traffic. How do you think they will push the traffic, or on the other side they will receive the traffic, right? So we can demonstrate this movement with some examples. So let's say if I have a user here and I have a user number 2 here. Let's say we have given him a rope, and we ask the user 1 to lift it. So let's say he has just lifted that particular rope. So let's say the wireless packet just went on and it tried reaching, but due to the loss of force, the packet just went till here and it got dropped. Okay, so this was not sufficient for your packet to send it to the destination. Now let's say the same rope, if we would have had some cycles, something like this. So let's say the data which was dropped from here went till here, the same data went once again towards the second cycle, and so on, finally reaches to the destination. So in the case of wireless, we represent the data flow in this kind of signals. Okay, they are collectively called as radio signals or radio frequency. In basically in the wired connection, we make use of a single wire and we demonstrate about data being sent. But in the case of wireless, we cannot draw a straight line because there's no one who is pushing it. We have to make some way we can send the packet in a better way, right? So we represent those radio frequency signals in this pattern. Okay, fine. So regarding the radio frequencies, okay, let me show you the range of radio frequency. So if you see the slide, the interesting radio frequency that we are focusing is on these two. Okay, it's also called as microwave and radar frequency. So it's a 5 gigahertz frequency and 2 dot. There are a lot of other frequencies which I told you we have in the case of air or wireless, like your the radio FMs, AMs, but we don't use it for the network or the wireless technologies. Okay, so in the case of the televisions and the radios, you can see here, this is the television frequency, this is the radio frequency, these are the low frequency radios. All your other frequencies like infrared, visible, x-rays, ultra UV, gamma, cosmic, they are above the threshold. The sound, the subsonic are somewhere below the threshold. Okay, so where does your wireless stand? Your wireless stands somewhere in this range. Okay, so between 2.4 to 5. Okay, so you have like something from 2.1 to 3, which is declared for wireless technology, and similar way in the case of 5, it is something from 4.8 or 4.0 to 5 dot something. Okay, that's been called as 5 gigahertz technology. So it's not straight away from 2.4 to 5. Don't be under that impression. So let's say I have 2.0, 2.1, 2.2, 2.4, 2.6, 2.8, 3, let's say 4, 5, 6, and so on. Okay, so the radio frequency which we are interested is somewhere over here, one set of frequency, and the second set of frequencies here. The rest of things are not declared as a wireless technology. Okay, we are not using them as wireless technology. It's just this particular set and this particular set. So in short form, we call it as 2.4 here, and we call here 5.0. So remember that. Okay, it's not straight away the complete bandwidth. So you know that the radio frequency or these electromagnetic waves, they don't travel like a straight line. They instead travel in all the direction. Okay, from the antenna. So if this is my access point with antennas, so I told you they will be emitted in all the ranges. Okay, and you know how do we represent them? Something like this. So what is the unit of this frequencies? So if you remember, these radio frequency, we make use of gigahertz, like I told you, 2.4 gigahertz and 5 gigahertz. From your certification point of view, let's say if someone asks you what is the radio frequency unit, is it a gigahertz, is it a kilohertz, is it just a hertz, or is it a megahertz, then you need to know that it's gigahertz. Okay, so it's something like this: hertz, kilohertz, megahertz, and gigahertz. Okay, this is the order for the frequencies. So if you see here this arrow mark, I can say that it's somewhere 3 kilo, not 3 kilohertz. So this signal over here, which is 3 kilohertz, and over here I can call it as like 300 gigahertz. Okay, So the entire collection is called as radio frequency. So out of this entire radio frequency collection, which includes radio communication, low frequencies, AM radio, shortwave, television, FM, microwave, radar, there's only one such block which we are interested in. Okay, the wireless technology, and the two majorly used is 2.4 and 5 gigahertz. Okay, now the exact frequency range. Okay, so there is a terminology here. We also call it as radio frequency. You can also call it as band. Okay, frequency is a range normally. Band is, we can call, so let's say I have a frequency of A to B, B to C, D to E. These are called as frequencies. But when I say band, I can say that the band B to C, band B to C. I don't have to say frequency here. Okay, so just it's about how we represent them. So similar way in the case of the numbers, the exact frequency, okay, the exact frequency, if I just talk for 2.4 point of view, it is 2.400 to 2.483 gigahertz. So this is that particular band used for wireless. Okay, 2.4 to 2.4.8, but we for simplicity just call it as 2.4 gigahertz because it's not feasible to remember the each and every band here, right, or each and every numbers here, so we call it as 2.4. Similar way in the case of 5 gigahertz, it's not purely 5, it's basically there are multiple ranges here. So it is 5.150 to 5.250, we have one set of band. We have 5.250 to 5.350, we have second band. The fourth band is 5.750 to 5.725, and there is one more band here which is 5.725 to 5.825. So this whole band we use for 5 gigahertz. But interesting fact is they are not a continuous frequency. I don't say that they are starting from this and they end at 5.825. That's not happening here. If you see them after 5.3, there's a huge gap, right? There could have been another band, but those band are still not been officially considered as wireless technology. Okay, there is a plan to make this the complete 5.3 from 5.3 to 547 to convert into wireless, but they are still under discussions. Okay, so it's not a continuous frequency range. They are couple of band here. These are the actual band which we use in the case of 5 gigahertz. Okay, for simplification or simplicity, we write 5 gigahertz. But always remember, it's not a continuous number. They are bands, and in between there might be one or two band which is still not officially considered as a wireless technology, at least for now. But there are chances that they will be getting sooner into wireless, but let's wait for that. Okay, let's talk from channel point of view. Okay, so I told you these 2.4 and 5, they are a part of wireless technology, and these wireless technology have very bad behavior of interference. Okay, so let's say if I keep a access point with two antennas and I have another access point with two antennas, so this is gonna emit its SSID, as well as this is going to emit its SSID. Now this portion is getting dropped. It's getting dropped due to interference between the two signals. And this is very common in the case of 2.4 gigahertz technology. Okay, So this topic about channel is to discuss why 5 gigahertz is better when we consider 2.4. Okay, so let me tell you, in the case of 2.4 gigahertz, to avoid this kind of situation, the interference, there is a concept that was launched called as channel. Okay, basically channels are nothing but they are some kind of number. So let me say, if this is the signal range, or this is how the signal look like. Okay, so let me draw something like x and y horizontal. So let's say this is x and this is y. Okay, so let's talk from the half cycle point of view. Okay, so first I'm talking for 2.4 gigahertz. So let's say this is channel number 1. Okay, so this would have been little better. Let me redraw. So let's say y and let's say x. So let's say this is one half frequency, this is second half frequency, and this is third half. Okay, so we have something like channel 1, channel 2, channel 3, channel 4, 5, 6, 7, 8, 9, and so on till 13. Okay, so let's say the whole signal was being split into half for our discussion. So the problem with 2.4 gigahertz is the width of the each wave is in such a way that they need 3 channel overlapping every time. So if you see here, if I draw this signal, okay, anything from here will overlap here, the second one will overlap here, the third one is going to overlap here, and so on. So basically they are overlapping. Okay, so as per the best practice, in case of 2.4, we developed this channel, and we are said, or we are being advised to make use of channels, so that we don't end up with interference. So let's say if I make use of channel 1 on this access point, channel 1, okay, what would be the channel number for access point 2? I'm not going to make use of channel 2 now, because there's a interference overlapping happening. So which is the best one where the interference is less? So from one point of view, the next best would be 6. So I am going to make use of channel 6 here. Okay, now this is an approach that we use in 2.4. We don't configure 2.4 and just keep it in a bulk, because then they all might be in channel number 1 and there will be a lot of interference. So we have channel number 1, we have channel number 6 on the second side. Now let's say I also had another access point, the third access point. So my 2.4, which one do you think would be the better one here? So let me draw over here. So let's say I have 10 and 11 and 12 and 13. Okay, so if you talk from the range, the next better would be the 11th one. So I'll say channel number 11 is better. Okay, so this way you will keep the channel number 1, 6, 11, the next number, and go on such way. So let's say this is for access point 1, access point 2, access point 3. In this way you have to set your channel number. Now this can lead to one of the disadvantage, because the channel numbers are repeated or limited, right? So if in case you have 3 access point, you have 3 channel number, you have 1, 6 and 13. But what if you have multiple access point? Now what happens is, you have to use the same channel number once again. So let's say 1613, you'll once again make use of 1613, and over here you will make use of 1 6 and 13. Okay, now you're back to your square number 1, the issue number 1. This and this overlapping, this and this overlapping, this and this overlapping, right? So basically 2.4 is not very good enough in terms of uh, the quality of packet. But if you talk from distance point of view, 2.4 is going to give you the longest range when compared with 5 gigahertz, because 2.4 can have like 30 meters. The standard is 10 meters for wireless, but some technology, some devices are capable of very high uh, broadcasting ranges or emitting ranges. So the 2.4 is said to be having the longest range. Okay, whereas the 5 gigahertz is considered for short range, but interference is very less in the case of 5. So let me tell you why is it less in the case of 5, why is it different than 2.4. Okay, so let's say in the case of 5, so the width of the signals are small, they don't interfere. So I can say that this is part of one channel, this is part of second channel, this is part of the third channel. So basically they don't overlap. In the case of 2.4, they were overlapping. So this was 1, this was 2, this was 3. But in the case of 5, each one will have their own channel number. So overlapping is very less here. Okay. So you don't really make use of channel concept in the case of 5 because they don't overlap. In the case of 2.4, they are going to overlap. That's why we make use of channel number. My access number 1 will have channel number 1. My access number 2 will have the second channel number where the overlapping would have been less or reduced or 0. Okay. So that's the major difference between 2.4 and 5 from the interference or uh, the overlapping point of view. Okay, now let's talk from the difference between the two. So let's say I have 2 gigahertz and 5 gigahertz. Okay, so you know that over here the overlapping is high. Over here overlapping is 0. What about the channels? Over here we make use of channels, but over here we don't really have to make use of channel. Okay, what about from the range? It's going to carry the long range, whereas this is used for just short range emission. Okay, so basically over here you have 3 channels which you can use when you have multiple access point kept next to next. But in the case of 5 gigahertz, you can say that there are many channels available. Okay, each one has their own channel. So basically you can make use of lot of access point in the case of 5 gigahertz without falling under the packet drop or such things. Okay, so basically 5 gigahertz was also earlier used for microwave and radar. Nowadays we use the same frequency for our wireless technology also. Okay, so that's about the frequencies. Now let's talk from security point of view. Okay, so we all know security is very major, is a major uh, part in case of in the enterprise, right? We are not going to send our packet over internet or over air without encryption, because anyone can steal the packet, or they can decode, and they can see what are you trying to run, or what are your device information and all other things, right? So security is very important thing. So even in the case of wireless, the security has been improvised. So long back, when wireless was just launched, they launched with just open authentication. So this was the first encryption method in wireless technology. So what is the prerequisite for open authentication? The prerequisite was your device must run on this. If you have a mobile and the mobile is having this kind of frequency adapter, now that mobile is capable of accessing access point SSID and can get connected to access point. That was the just prerequisite. It was not a full-fledged authentication or encryption, right? Anyone could have connected now. So that is why the need for a better option was released, okay, or was required. So the next one was called as WEP. WEP is something which started using, okay, so started using passwords, password in string format, okay. So this was a mechanism where we started using some string password. So every packet that was in the air were protected with this kind of passwords. So each packet in terms of password. So basically, if this is a user device and this is access point, so any packet between these two, they were all being password protected. Now that was okay, but later on that was again something which was easily decodable, right? Anyone could have decoded and just used it. So the need was to bring in something better. So then they found out another method which was called as 2.1x, which is a part of .1x patent, okay. So under .1x, which very similar work as your SSH or your AAA concept, okay. You have your user, okay, who is trying to make a SSH on your network device. The network device which is connected to AAA server is going to form the negotiation and then release the console to the users, okay. So we call this user as supplicant, we call the network device as authenticator, and we call the AAA server as authentication server in from the technology point of view, okay. So if you just break down, it's nothing but the user making SSH connection to the box. SSH connection will see its AAA configuration, which says that the first priority is onto the server, the AAA server. They will send the packet, the AAA server will check its internal database and then will say, yes, he is a legitimate user. And the device is gonna send a open console message. And that's how the user is now connected to the box, okay. So you are going to set all the policy, what kind of user he is, whether he is a privileged 15 user, whether he is allowed to do all the read and write, whether he is allowed to run all the show command. So that's all policy set under this, okay. So this kind of technology was now integrated with the wireless as well. So your access point these days will also offer encryption which supports this, okay. And you know what is backend happening here. So the basically the access point can be connected to AAA. So if you have the user with the handheld connected to AP using SSID, he will input username password which will go to the backend and whatever things that we discussed just now, okay. There's Better, there's one more way which you might have heard and which we are using most of the time. We call it as WPA, WPA2, WPA3. So this is the encryption method that we widely use. Okay, and right now lot of access point, they come along with this encryption method, the 8.1x and WPA. Okay, so if I just go to my adapter, if I click on the change adapter option, if I go to my wireless that I'm connected right now, I can show you what kind of encryption my device is recognizing. So I have open. Okay, so if I set none, so basically anyone can connect. Okay, without any username and password, anyone can connect. It just need the prerequisite of 802.111. So that was not a better option. So later on we started up with WEP, which was asking for some password, a string of password. Now you know that it will not take much time to decode that password. So later on, WP authentication, no authentication were all converted to .1x. Okay, so you can have WEP and you can have the other configuration over here like certificates, protected EAP. I told you. So EAP is a protocol which is used in this technology .1x. Okay, so we have the three steps here. We have supplicant, authenticator, and authenticator server. So basically these packets, they are all over on EAP. Okay, these kind of protocol. And what is the latest encryption method that we have? We have WPA2 Enterprise, which support AES. AES is very secure. Okay, so you have WPA2 Personal, you have WP3 Personal. So these are all advanced things. Okay, and these are widely used now. So right now that I'm using is I'm using WPA Personal with AES. This is the encryption method that I'm using right now for my wireless technology. So my wireless packets are secured. Okay, so most of the guys would be having the doubt, how does we secure the wireless packet? So we secure this in this way. Fine. So the last topic here for the day is the deployment. Okay, so basically that will be the last topic. Deployment mode of your I won't say access point, I would say that Cisco WLC. Okay, now let's bring in this concept which is called as wireless LAN controller. So why do we use controller in enterprise? So we were discussing about one access point, two access point, three access point, right? There could be enterprises where you have thousands of access point. Okay, so as a network administrator, you just cannot log into each access point for troubleshooting, for monitoring the threshold, or to see the MAC address or see the threats or upgradation, right? You need some centralized way. So what we do is we have a Cisco WLC box. Okay, so this is a hardware which is connected to the Cisco switch, and all the access points will be connected with these boxes. So they don't have to be really connected with WLC, they can be connected to the switch, but they have to be in the same network. So let's say WLC is on 192.168.1.1 series. So I'll make sure the other access point are in the same network so I can manage them. This is nothing but it provide me the graphical interface. Okay, so this WLC will offer me GUI interface. Over on the GUI dashboard, I can see all my access point in a graphical representation. If I click on one access point, I can see its graphical view. I can see what is the threshold, what is happening there, how many users are connected right now, what is the usage happening. I can also push the configuration. Let's say there happens where all this access point are running on pretty older image version. Okay, and my management asked me to upgrade them to whatever is the latest version. So let's say 5.x is latest version. I don't have to manually go on each one, upgrade them. I can just take the control from my WLC controller. So I can just push the configuration from my WLC itself. Okay, so WLC act as a centralized controller to handle all your access point. Now in this topic we will talk about the deployment mode for WLC. Where do you keep this WLC? Do you keep it in the distribution layer? Do you keep it in the cloud? Do you keep it somewhere very near to the core layer, or where exactly you keep it? Okay, so this topic will be like to discuss WLC deployment. So we have four ways, or we have four ways that we can prefer one out of it. So we have the first method called as unified WLC deployment. Okay, the second one over here would be cloud based WLC deployment, and the third one over here would be embedded WLC deployment, and the fourth one would be called as Cisco Mobility Express WLC deployment. Okay, the four ways that we can deploy the WLC. Okay, so let's see the first method. Let's say, what do you understand by unified? So this is a mechanism, or this is a deployment method where the WLC will be kept somewhere in the edge of your enterprise. So let's say I have a core device, I have my distribution, and then I have my access layer. So my unified WLC will be kept somewhere in the edge. Okay, so it's more closer towards your ISP. So you have any policy or anything that's coming in, so you have your WLC somewhere very closer to that. That's the first approach or the deployment method. So basically you can set your policies and all other things, so it's easier for the users, because might be some users don't have to be connected to internet, so you can set it because that's very close towards ISP. Some needs internet, so you can say that it's been allowed. So basically this is your gateway device, all your gateway are on this. So let's say this is VLAN 10, which is on 1.1.1.100/24. So where is the gateway? Gateway is on your core with 10.1.1.1/24, right? So all your packet are hitting your core. So it is easier for us to deploy the unified controller here, and we can set the policy whether we have to allow this person to internet or no. So this is unified. What do you understand by cloud based? So as the name says, it's something where your WLC is kept in the cloud. Might be in the data center, okay, or might be you have some private cloud. Might be you have AWS, GCP, or Azure, right? So let's say I have my core, I have my distribution, I have my access layer, okay. And where is my WLC kept? My WLC is kept in AWS private cloud, okay. So let's say I have unified WLC. So this is the second deployment method. The third deployment method is embedded WLC. Now what do you understand by embedded? Embedded is one such feature when, let's say, you're using it for users like, or for, let's say, for APs like 150 to 300 APs, okay. Over here you have thousands of AP. Over here you have again thousands of APs. Now this is the requirement for just 300 APs. You don't need lot of access point, might be because there is no a lot of users sitting there. So embedded VLC is one such feature where you have stack concept, right? So if I talk about stack devices, the stack switches, you can place your WLC within them. It's a embedded in nature, okay. So you can have your WLC card in the stack. So you have your core connected to distribution, distribution connected to stack, stack connected to the end users, okay. This is a embedded uh, technology, and it supports like 150 to 300 access point. So the last feature here is called as Cisco mobility, and this is when you need very less access point, might be up to 100 access point only, even lesser than this, okay. So when you have like 100 access point, you can make use of Cisco mobility deployment method. So basically the Cisco mobility feature will not support all the features that your embedded and cloud and unified were supporting. They are going to support just normal, or I can say the basic features only that's required to run your enterprise, okay. So I can say this is used in the branch office purpose, okay. So these are the four deployment method depending upon how you use, where you use, and uh, what you use, okay. All right, so that ends the topic for the day. Let me see if I'm not missed anything. So channels 2.425 hertz encryption, the deployment, okay. And yes, regarding the Wi-Fi community, okay. So before that, let me show the Cisco Aeronet price. So you can see the basic one like $600. So you have still more a basic with 168.72. So basically these are some very lower end devices, okay. So the community here is called as Wi-Fi Alliance. So these are the community which is responsible for the wireless development. So wireless or Wi-Fi 6 or whatever it's regards to the Wi-Fi encryption, Wi-Fi 6. So it's all been documented here. Okay, so this is the Wi-Fi alliance, and they are free. They are open source. Okay, so anyone can work on this technology, can contribute, can give software updates. All right, fine. So let me know if you guys have any doubt, and then we'll take it forward from there. Okay. Okay. So looks like no doubt. The topic was pretty simpler and pretty easy to understand. So if everything is fine, I'll take it as no, there's no doubt from anyone, and we are good to meet in the next class. All right, guys. So I think it's all clear. I'll pass on the video as well as the PDF on the web portal. So let's meet up in the next class, and have a nice day, and see you soon. Okay, have a nice day. See you.